welcome to trèSci Weekly, episode 20. Today is Monday, June 19th, 2017. I'm one of your hosts, Jonathan Ullman, alongside Every Kiss Begins with Tom Katia. You like how I did that one this time?
Yeah.
Yep. I boiled in the K. Yeah. That was good.
Good jokes.
Thank you.
Happy to be here as always.
How are you, my friend?
Good. Very stoked. Episode 20, man.
I know.
We've been doing it.
That
Feels weird.
Yeah.
It still feels so new, but episode 20, I'm proud of us.
5 months in. I'm proud of us too. Yeah, me too.
I'm proud of me. That's all I have to say.
Exactly. Yeah. Anything noteworthy to talk about before we begin?
Yeah, the NASA Wallops is postponed again. So we're not going to watch that stream. We already know it's postponed again.
Which is nice. That means we don't have to
check live and get disappointed again live.
Yeah. For those of us who watched last episodes, or for those of you guys out there who watched last episode with us, we cut to NASA Wallops is launching a mission to study the dynamics of the ionosphere, and they've been
teasing us since June 1st that they're going to launch, and then there's all kinds of issues.
Yeah, every night it's like they get down to the wire, and then it's like, oh, never mind, we scrubbed it for this week. So it's not happening again this week or tonight. So we'll keep you posted on that, I guess.
Yeah, but whenever it does happen, we'll let you know the results.
Yep. Happy Father's Day to all the fathers out there. Yesterday.
Yep.
Did you do anything nice for your dad?
I made him pancakes.
That's awesome.
That's pretty cool.
Yeah, right on. Very cool.
How about you?
Yeah, went to Bertucci's with Pops. Yeah,
that's nice.
That's always the hot spot for us. Yeah, and then other than that, summer solstice coming up this week.
Yeah, longest day of the year.
Heck yeah.
So if you have something good you want to do, that's the day to do it.
Yeah.
The longest time to do it.
Exactly. Other than that, pretty uneventful week, I think. Pretty just mellow. Didn't work as much. Feeling nice and refreshed today, so that's good. And Mush is doing good over there, sniffing the old computer bag. All right, so thank you for joining us. Welcome to the show. If you're new to the show, this is our weekly video podcast where Tom and I discuss science news topics that are kind of trending, and we offer our thoughts and opinions on them. We are totally crowdfunded by our subscribers. New updates to Patreon, actually, Tom.
Oh, nice.
Yeah, I don't know if you saw that. They kind of revamped the website, and so we should. I know we talk about it week after week, but we should definitely take a revamp of our own Patreon. Big shout out to our Patreon supporters out there. You guys keep this show kind of alive and well, and allow Tom and I to do this week after week. So thank you guys. Of course, if you'd like to become a subscriber to us on Patreon, you can go to patreon.com/trèSci Weekly to support us there. But know that you don't have to. Of course, these videos will always be free. You can also support us by subscribing to us on our YouTube page, liking us on facebook.com/trèSci Weekly, and following us on twitter.com/trèSci Weekly. And with that,
we'll hop right into the news.
Yeah, we'll hop right on into it. There are 7 stories this week, Tom.
So we can't be chatty Cathy.
No, can't dilly-dally. There were only going to be 6, but then NASA had to go and have another press conference today, this morning.
Yeah.
I watched it, most of it live. I missed the very beginning of it, but I caught the tail ends. So that's what we're going to lead with, because it's the most breaking news.
And
so
you can watch it live on their YouTube.
Yeah,
right.
NASA.gov/live, I think.
And you can just watch it there.
Yeah.
Okay.
And it's on their YouTube as well. So we'll jump right into that. Number 1. In a press conference today, NASA's Kepler Space Telescope team announced that the final catalog of planet candidates from the Cygnus constellation contain the best characterized data yet. In it, the team introduces 219 new planet candidates, 10 of which are near Earth size and are located within their star's habitable zone. The data also suggests that small planets are prevalent throughout the galaxy and come in 2 distinct types, dubbed super-Earths and mini-Neptunes. And we have a couple images there, graphics that we can bring up if Kyle doesn't mind bringing those up for us.
So we're starting the catalog of planets, basically.
Well,
the Earth-like planets.
Yeah, we've had a catalog of exoplanets for a while now, and so now we're
getting enough information to actually categorize them meaningfully.
Right.
As opposed to just saying we have X number of them.
Exactly. Yeah. So enough of this data is coming where now we can categorize them into Earth-like and habitable zone regions, and
because there's quite a number of them now.
Absolutely. Over 4,000 candidates
total,
and over 2,000 confirmed exoplanets out there now. So we can see from the data that small planets are common. In the first chart there, it says, kind of gives us a histograph of planets that are compared to the size of the Earth in terms of radius. And so 1 times the size of the Earth would be exactly the same size, and then they kind of get a little bit bigger and then drop off there a little bit.
So similar to the size of Earth is pretty common, like 2 to 3 times. It's not a drastic change.
Yep.
So small planets are common.
And then if we kind of zoom in there a little bit, we see on the next graph, small planets come in 2 sizes. And this was really the take-home point for me during this press conference, is that
we're actually getting meaningful categorization of the exoplanets.
Yeah, and what we're finding here is actually the highest number, the highest frequency of planets or exoplanet types that we see out there are these, what they call mini Neptune planets. So they're gaseous planets presumed to be a bit smaller than Neptune's radius in our solar system. And then just below that, and there's a clear kind of gap in the data there, just below that in frequency, there are what they call super Earths, right? So terrestrial planets that are just a bit larger than our own Earth. And that's really interesting to me, because if that's the most common type of exoplanet maybe out there, then why aren't either of those type of planet within our own solar system?
Yeah, so that is definitely very interesting, how we see these being common. But I guess when you look at the overall picture of how many exoplanets are probably in the entire universe, we haven't nearly scratched the surface at that data, right?
Yeah, of course.
So it might be a little bit skewed, but really weird that all these exoplanets that we do observe aren't like the planets in our own solar system.
Yeah.
So like you said, they're Earth-like planets but bigger, like super Earths. And I think I was reading that they take in some extra hydrogen for some reason, and they can accrete a little bit more mass than we would normally expect.
Mm-hmm.
And then you said the small Neptune ones, so even smaller than Neptune, so obviously a lot smaller than Saturn and a lot smaller than Jupiter.
Right.
So not really like our solar system of the common planets that we're seeing.
Right.
But interesting nonetheless.
Yeah,
really cool.
Really, really interesting. So there is a short video that we can cut to that kind of sums up all the sort of points that they made during the hour-long press conference today.
Sounds
good.
We'll
flip over to that. Not yet, Kyle's telling me. Do you not have the link? Uh-oh.
Uh-oh. Ladies and gentlemen,
do you want me to send it to you really quick? You got it.
It's been removed by the user.
Oh, really? It's been removed by the user. All right. Well, then forget it, I guess.
Okay.
If that's how they want to play it, I guess we'll just we'll skip that part.
Yeah, so it's just like a quick little summary of
Yeah.
them finding new information, cataloging exoplanets.
Exactly. So I guess how I'll sum this up is with a quote, actually.
Okay.
According to Susan Thompson, one of the Kepler scientist panelists at the conference, quote, "This carefully measured catalog is the foundation for directly answering one of astronomy's most compelling questions. How many planets like our Earth are in the galaxy?" End quote. And so now what they think, Tom, is with this last data dump from this original Kepler mission, that they now have the pieces that they need to accurately answer this question.
And that's throughout our galaxy. Yeah.
Right. Because there shouldn't be any preferentiality towards this particular piece of the sky that Kepler is looking at. I mean, we can essentially extrapolate throughout our own galaxy. Conditions should be...
The physics are the same
exactly
in the universe.
So That's really exciting, man. That's
Yeah.
really, really cool. A huge step.
It went from, I felt like being a kid as, just very skeptical, like thinking, is there life? It kind of was like, maybe, I don't know. It's cool to think about, but now it's like we're actually taking the steps to catalog it, and really, you can almost see it come to fruition when we really know how many Earth-like planets are in our galaxy, and as we narrow down the habitable zones and what might be the atmospheres and things like that. It's pretty cool stuff.
It's very exciting. All right, moving on.
Sounds good.
Number 2. Scientists have developed a topical drug that induces melanin production in human skin without the presence of UV rays. Targeting and inhibiting the gene responsible for the production of an enzyme known as salt-inducible kinase, researcher Nizma Mujahid and colleagues were able to trigger melanogenesis,
Yes.
or the production of dark pigmentation in the epidermis.
So right off the bat, just so we're all on the same page, melanin is what makes your skin a darker pigment, right?
Exactly.
So
Yep.
they're saying they've found a way to topically put it on, and they're testing it on mice, we're going to say, but to make the skin darker.
Correct. Yep. And so your skin kind of makes its own melanin as a
you're out
response to
UV rays.
And in this case, you don't need to use UV rays in order to trigger it. It's just kind of going into your right. It's doing it at the
biology
level.
of the epidermis.
Exactly.
Yeah. So, which is exciting because what do we all say about UV rays, right? Don't lay in a tanning bed all day, or because that's dangerous.
Yes.
So being able to get the results of that are pretty awesome. But we'll talk about that as it goes on.
Yeah. The first wave of testing was conducted on red hair mice, which lack production of melanin due to an inactivating mutation in the melanocortin-1 receptor, or MC1R gene. Quote, darkening induced by topical application of HG99101 to MC1R, and HG99101 is kind of what they termed this first drug, basically.
Okay.
To
beautiful name.
Yeah. To this type of mice, was progressive over 6 days of treatment and gradually reversed over the 2 weeks after treatment was stopped. Skin pigmentation remained in its pre-treatment state 26 days later, 40 days after treatment ended. And we have an image of what the mice kind of looked like. So we'll bring that up for you real quick. And you can see, so day 0, before the treatment begins, you have your kind of array of mice that they're going to be testing. The left 2 are albino mice. Those are basically used as a control in this experiment because
they
albinism
don't develop the pigment at all.
Exactly. You just cannot produce melanin. That is what albinism is, basically. And on the right 2, they have what they term a vehicle, which is also kind of like a control. That's just in order to make sure that the process by which they applied the drug isn't triggering the response.
Okay.
So that one is also, in a sense, a control. And then on the rightmost mouse, that's where they're going to apply this new drug, right? Mm-hmm. This new skin drug. And you can see on day 6, the rightmost mouse has a much darker complexion, which is pretty cool. And then as time goes on, it fades, and the mouse's skin returns to kind of a normal pigmentation without it. So that's nice. That means the effects, cool. Melanin's not going to just live in your skin forever, which is nice. So, albino mice, as I said, were treated as a control since albinism means the complete absence of pigment, and thus even application of the topical inducer will not trigger melanin production. Then the next challenge was developing SIK inhibitors for human skin application, since the human epidermis is about 5 times thicker than a mouse's. Quote, treatment of human skin explants with passive topical application of the second generation SIK inhibitors, YKL-06061 and YKL-06062, induced significant pigmentation after 8 days of treatment. Once per day was the treatment, end quote. And so we have an image of that one as well. So, bring that up on our end. All right, and so again, you can see the vehicle, the control vehicle application of just the original drug that they used on the mouse. Doesn't work very well. The drug that they used on the mouse doesn't work very well, but then these two kind of modifications to the drug for human skin, this first one here actually, YKL06061, seems to work even better than the other modification that they made in darkening the skin. So that's awesome.
Pretty cool.
So the team believes that this could potentially be used not as a substitute, but in combination with sunscreen to help protect fair-skinned people from skin cancer.
So that would be the end goal.
That's the end goal, right?
Yeah.
Image credit goes to N. Mujahid et al. For this information.
So it's still in like super early trials where they don't know the exact amount to put in to get an exact pigment, right?
Right.
At this point. So they just know how the mechanism works, and they're kind of getting into applying it to human epidermis.
Correct.
As well.
Yeah, so clinical trials haven't really begun as far as like testing this on widespread on people. So still probably a ways out before we might see this as a commercial product. But interesting nonetheless. I mean...
Yeah, we were talking about it before. I wanted to bring up that like a lot of people don't use sunscreen as they should because they want to get darker, they want to get tanned.
Absolutely.
But imagine something that tans your skin while protecting you from UV rays. That would be awesome.
Yeah.
That'd be great. That would just help everybody.
Totally. As a fair-skinned person, I couldn't be happier with the development in
things like
this. I mean...
Yeah, especially when you don't have hair either and the sun's on it. It's tough.
It's funny, man. I get ridiculed for being as pale as I am. Like, cause
why are you so pale?
Right? It's like, I don't know, man. It's not my choice.
Because when you do go in the sun, you get pretty red.
Yeah. Yeah. And then it like, it's not even like sunburn always. It's my skin just gets irritated, I think, and then it goes away kind of quickly, and then I just stay pale. I mean, I'm out in the sun cleaning pools like day and night every day, and I'm still pretty pale, like relative to Kyle over there. So this is cool. This would be a great thing. Because I know a lot of people like to go tanning.
Also, like if you have eczema or other things, if this could just be like sort of like another coating on top of your skin to allow you to be out in the sun all day.
Exactly.
Like if you needed to go to summer camp or something like that.
Yeah. It would be really funny too to like make.
You can make designs.
Make designs and write things on the skin and like have it show up.
That'd be so fun.
Just like when you catch somebody sleeping on the beach and you make a sunscreen.
But this one just stays on them for weeks.
Yeah, could be dangerous actually.
And it has prank applications. They forgot to mention that.
All right. Moving on. Number 3. With the help of slow motion cameras and an artificial transparent elytra, the mechanisms behind how a ladybug folds its wings have finally been uncovered. Japanese researcher Kazuya Saito and colleagues were inspired by how, quote, hind wings in ladybird beetles successfully achieve compatibility between the deformability, or instability, required for wing folding, and strength property, stability, required for flying, end quote. This balance has remained a mystery since ladybugs close their elytra, or the red and black polka dot part of their wings, prior to folding the hind wings. So, the team replaced a piece of the elytra with a transparent resin on living beetles and filmed them unfold the wings in preparation for takeoff, and then detailed the refolding mechanism upon landing. And we actually have some videos of that to show you guys. Yep.
Feels weird to call a ladybug a beetle because they're such ladies. I call them a beetle.
So we'll bring those up whenever you're ready. Yep. I always love watching things in slow-mo.
Right?
It's so cool.
This one's particularly cool.
Go Gadget Ladybug. All right, and then we have one of the folding mechanism. So we'll swap to that one. right? And so this is the problem, is that the elytra closes and we don't really understand how the
How they get in
ladybug
there.
folds up that wing. But now, with the artificial elytra, and they'll freeze frame it for us piece by piece. The elytra are closed ahead of the hind wings. Held by the elytra on the wing is slightly folded in the transverse direction. Two transverse folding lines, PTF and ATF, are firstly introduced by the ventral curve and the edge of the... I didn't get to read that whole thing. The ATF drifts toward the apex of the wing by abdominal push, and the wing is gradually retracted. So it uses its butt
to push it.
Yeah. The hind wings are folded into a Z shape on the folding lines of PTF and ATF. There you have it. And then the last video is just a 3D rendering that they used, kind of a computer-generated 3D rendering of what the folded wing looks like. So we'll bring that up.
All right.
And so you can see that Z shape that they talk about, which, if you can imagine that first image, first video again, how that thing just kind of bursts open before they start to fly. So pretty cool. The shape of the wing veins provides strength but bendability, similar to a metal tape measure, and the abdominal motion helps explain how the wings fold along diamond-shaped creases, much like origami. And the researchers provided an image of that diamond shape that they relate to origami, which we'll bring up for you in just a second. So, yeah, I mean, that's pretty awesome, right?
Yeah.
You can like see that same diamond structure in the paper folding right there in the wings.
Yeah, so it's really cool that, because we didn't know how they get that folded structure in a wing that is also strong enough to fly the ladybug.
Right.
So that was sort of the trick, right?
Right.
That's what they were trying to figure out. Like, how can we do something like this? How can we get something strong enough as well to fold in at the same time like that?
Yeah. And yeah, just to finish up here, the research may go on to help engineering innovations in aircraft or deployment of solar panels on board spacecraft. Video and image credit goes to Saito et al. For that. But yeah, exactly like you're saying, Tom, this is another example of borrowing from nature in order to help innovate our own practices.
Our new technology.
Yeah, our new technologies. So I always like that kind of stuff, because nature knows best, man.
Yeah, we learn a lot of stuff from nature. We were talking about before, like the pants from Dockers, where you could like spill milk on them and it just runs off.
Yeah.
We got the hydrophobic nature from looking at the nanoscale in animals.
Yep.
And we're like, oh, let's mimic that. We want to do that.
Absolutely.
Here's another case where we could take the physics of the ladybug wing and maybe use it in our own machines.
Yeah.
Cool stuff.
Really cool stuff. Now, I want to bring up something just as an aside here. Ladybugs, totally adorable, right?
Yes.
If you were covered in ladybugs, I don't think anybody would freak out about that, right? I mean,
I might not be happy about it.
yeah, but you wouldn't be like terrified, right?
Probably.
Why do ladybugs get a pass? You know, like if I was covered in spiders, that would be not acceptable. Not at all.
Well, do ladybugs bite you? I don't know.
No, but like daddy longlegs don't bite you, but that would be horrifying.
I guess it's a combination of the name lady and the nice color scheme.
The polka dots,
And
dude,
the polka dots.
right?
Polka dots are cute.
Yeah.
I don't know.
I'm just saying, some bugs have it easy,
And some bugs
don't have it easy, and that's, I don't know why.
I think that's the take-home message of A Bug's Life, if you've ever watched it.
I have watched it. I love that movie. That's a great movie. Cool. Moving on. Number 4. Researchers at Google's DeepMind, an artificial intelligence neural network based in London, UK, have developed an algorithm for relational reasoning, or the capacity to use logic for comparing things. This marks a big step for AI networks which have excelled at pattern recognition but struggled to adopt relational reasoning, a skill that humans are quite adept at. According to the paper submitted by Adam Santoro and colleagues, the relational network algorithm is a, quote, plug-and-play module, meaning, quote, the capacity to compute relations is baked into the relational network architecture without needing to be learned. Without needing to be learned, end quote there, each time a new question or task is introduced.
So it sort of just knows how to do this reasoning.
Right.
It doesn't need an input every time a new type of relational question is asked.
Right.
It sort of just knows that now.
This module exists outside of each individual routine, I guess, that this network goes through in
then
order.
it can come back and rely on it.
Right.
Okay.
So I don't know a whole heck of a lot about computer science and all that kind of stuff, but I do know that you try to build code where you don't have to rewrite the same code over. Right. So you try to bake it into modules that the network can then go and call upon in order to perform functions. So that's cool. The team tested their relational network on a visual data set referred to as Clever, where the neural network was tasked with answering questions comparing the properties of one object in an image based on properties of the other. And I have an image to show you guys that gives you an example of what kind of relational questions they were talking about. So we'll bring that up quickly. And so here we go. So you guys can see the picture of the objects, the shape objects there, and an example that the authors of this paper give of a non-relational question would be, what is the size of the brown sphere? Right? So that's just intrinsic. You either know it or you don't, or you can measure it or you can't sort of question. And then their relational question example that they give is, are there any rubber things that have the same size as the yellow metallic cylinder? And for that, that's a relational question because you need to know something about the yellow cylinder in order to compare the other objects to it. And so that's a relational question there. So this is something that AI has struggled with forever, right? This is something that we've not been able to build computers to be good at, and now for the first time. We were saying like this is a human-like thing, but it's really not. It's just a harder way to, not a harder way, but a thing that needs to be adapted for AI. Right. So here we go. Results showed that, quote, our model achieved state-of-the-art performance on Clever at 95.5%, exceeding the best model trained only on the pixel images and questions at the time of the dataset's publication by 27% and surpassing human performance in the task, end quote. Humans were capable of answering the relational questions correctly 92.6% of the time, so still respectable, but unbelievable that
the AI
is
already doing it.
Already better than us. Image credit goes to A. Santoro et al. And DeepMind Technologies for that. And I want to bring this up because this is somewhat terrifying to me, right? I mean, I feel like we're playing with fire here.
Yeah, it seems like we're almost getting to the point where once we give it this idea of relation, like when does the AI step out and like realize its relation to us? And you know what I mean? Like once it knows too many relations, like, you know, that's where it does get kind of sketchy.
Yeah.
I mean, at this point we're safe totally.
Of course. It's fascinating, and I understand the importance of furthering this kind of like AI neural network and why this would be really useful for research, right? I mean, like
you could just ask it infinitely more questions if it has this ability.
Yeah. Actually, so what's interesting is the reason why things like Galaxy Zoo exists. Have you ever been to Galaxy Zoo?
No, I haven't actually.
It's basically a set of scientific research that is kind of outsourced to the public in doing relational tasks, right? And it started with galaxy recognition. So this program would basically grab images and ask users a bunch of different questions to see if they could classify objects in the image as galaxies, right? Like,
Okay.
hey, is this elliptical or is it spiral? Do you see, 2 spiral arms, 3 spiral arms, like X amount of things, and then that would get sorted into further data sets for scientists to then perform experiments with or analytics with.
So
or
the only
whatever.
way for them to get that data is to outsource it to people.
Right,
But
because
now
people are better
At
at
recognizing
relational.
relations.
Right. And now that's
this gets
maybe
developed.
maybe no longer the case, right? So, I guess that hurts Galaxy Zoo, but
Yeah.
yeah, that's the immediate sort of thing you have to contend with. But
There's plenty more citizen science out there.
Oh, of
for
course.
us,
But I think going a few steps further than that, it's like, well, how much smarter are these AI networks going to become, and at what point do we, are we contending with them in a sense? Like we are always kind of in control because computers are dumb, right? We tell computers what to do, but not if we build them to think like us. You know what I'm saying? Like,
yeah. I do see what you're saying.
yeah. It's definitely crazy. So there's that. How's the chat feel about this stuff?
James says he's not surprised. he knows that AI is taking over.
Yeah.
He's already come to terms with this robotic overlords.
Yeah, that's good. That's good. All right, moving on. Number 5. MIT Media Lab revealed a new project called Dermal Abyss, a proof-of-concept research initiative replacing traditional tattoo ink with biosensors that change color based on variations in body chemistry. So far, 4 biosensor inks have been tested using a pigskin model. Quote, the pH sensor changes between purple and pink, the glucose sensor shifts between blue and brown, and sodium and second pH sensor fluoresce at a higher intensity under UV light, end quote. And we have an image of that. I don't know, Kyle probably actually already brought it up for you guys, maybe.
You'd be the life of a party if you had a tattoo that lit up under UV light. If you went to like a club or something.
Well, they do have
those
UV ink already.
Oh, they have the UV
Yeah.
ink. You're right.
But yeah, this is pretty cool because it responds to like changes in your body's own
Yeah, this is
pH
cool.
level. Yeah,
You're
this is great.
Don't forget what I said.
And we do have a video also that kind of sums this up a little bit better than I said it. So we'll flip over to that. And we'll throw the earbuds on. The earbuds.
The Airbuds.
Yep.
Golden Retriever.
Kyle, give me the point when you're ready. Here we go.
Can tattoos embrace technology in order to make the skin interactive? The dermal abyss presents a novel approach to biointerfaces in which the body's surface is rendered an interactive display. Traditional inks are replaced with biosensors whose colors change in response to variations in the intestinal fluid. The pH sensor changes between purple and pink, and the glucose sensor between blue and brown. The sodium and second pH sensor fluoresce at a higher intensity under UV light. The dermal abyss creates direct access to the compartments of the body and reflects inner metabolic processes in the shape of a tattoo. It could be used for applications in continuously monitoring, such as medical diagnostics, quantified self, and data encoding in the body. Preliminary evaluation was done in an ex vivo pig skin model. Several injections in the skin were done in order to understand the visibility and functionality of the biosensors. In the same way that the wearables industry is integrating fashion practices into their development, we envision new participation between the biotech companies and skin professionals, such as prosthesis experts and tattooists, in order to embrace the idea of human-device symbiosis.
There we have it.
Yeah, that's pretty cool.
Very cool. So image and video credit goes to Jin Liu, Katia Vega, and MIT Media Lab for that one. Yeah, so this would have obvious implications for people with diabetes, for them to be able to monitor their glucose levels without having to do the pricking.
The pin prick.
Yep.
Which, I think a lot of people would like to have a style tattoo that they picked out as opposed to taking their own blood every day.
Yeah.
I mean, that's pretty cool.
Yeah. So right there, I mean, that's
already cool.
That's already cool. And I mean, who knows what other sort of
things that you can monitor.
Yeah.
Maybe everybody has like a cool bio tattoo.
Right.
That'd be really cool.
I would love that. Yeah.
Someone looks at your arm and they're like, "You're a little dehydrated, man."
Yeah. Yeah. That would be awesome.
That would be cool.
Really, really cool. So we'll see how that goes. The website here sort of makes it clear that this is just for research purposes as of right now.
At this point.
They're not really looking to make this into a commercial type product. But I think it's only a matter of time before
that
something like this catches on. Yeah, I mean, I would get one.
Yeah, really.
Why not?
Cool, right? I don't have one yet, but it would give me a reason to get one.
Yeah, definitely. All right. Number 6. Back on September 27th, 2016, Elon Musk gave a presentation at the 67th annual meeting of the International Astronautical Congress in Guadalajara, Mexico. The hour-long talk titled "Making Humans a Multiplanetary Species" was made available on SpaceX's YouTube channel and has just recently been transcribed into an essay format by Stanford University professor and editor-in-chief of New Space, Scott Hubbard.
Yeah, it's really cool to read. When you're reading it, it almost seems like a science fiction novel, but then you're like, oh wait, these are legitimate logistic plans to go to Mars.
Yeah.
Really cool.
It's really
almost as entertaining though.
Yeah.
Cool stuff.
In it, Musk speaks to the importance of making space travel to Mars cost-effective for the average citizen, stating, quote, "If we can get the cost of moving to Mars to be roughly equivalent to a median house price in the United States, which is around $200,000, then I think the probability of establishing a self-sustaining civilization is very high. I think it would almost certainly occur," end quote. Musk and SpaceX seem determined to tackle the challenges of making this a reality, outlining several key advancements such as full rocket reusability, fuel refilling in orbit, and propellant production on Mars as the next logistical steps. Ultimately, this is somewhat old news, but Musk provided a teaser for an update via Twitter, where he says, quote, "Colonizing Mars, thanks Professor Hubbard for creating this form of my talk. Major changes to the plan coming soon." When a Twitter user named John Ross commented asking how soon, Musk replied, "So soon you won't believe it." So, we can expect an update to what SpaceX is doing, I think probably in the coming few weeks, which is really awesome. I encourage all of you guys to go out and read this short essay. It's, I don't know, a few pages at the most.
It's cool too. It's got graphs and pictures.
Yeah,
it's cool.
It's really cool. I didn't want to spend too much of our own time, going back over it because it it's from late last year.
But now you can just read it. So
yeah.
And Nancy in the chat, pretty funny. She's trying to move now. Pretty difficult, so why not go to Mars?
Yeah, right.
It's difficult enough to move here. Very true.
That is true. So for $200,000, Tom,
would you go to Mars?
That's the question.
I don't have $200,000, and we just invested into this house. But if somebody wanted to buy ours, maybe I could convince Chrissy to move us on to Mars.
Yeah,
like look at the opportunities. There's plenty of teaching jobs on Mars because there's nobody there. Yeah, but you could be the first teacher.
Yeah,
no, but I would be all about it.
I feel like
I think it would be an adventure of a lifetime.
I feel like I would jump at the opportunity to move to Mars because Earth is awesome. Don't get me wrong. I like it here.
But I mean, that's where everybody's been forever, right?
Right. I just think back to the pioneers, right?
Yeah,
the people
they
that
didn't really know what was out there, and they still went anyway.
Yeah.
And now look at us.
Yeah. The people that came from overseas to the Americas for the first time and were like, hey, we're just going to sail over there, We'll make it work. And then
this place stinks. We're going over there.
Yeah. And then upon, building a civilization here on the East Coast, and then you have people like Lewis and Clark who were like,
expand that.
You know what? We're just going to go west. We don't know how far west goes, but we're just going to go until...
Yeah, that's cool stuff.
That's so awesome. Like...
What's really cool, too, is whenever you start over again, you get to sort of rewrite the rules, right?
Yeah.
Like, we didn't have a constitution until we got here. It's not like we made it. We didn't have a sweet game plan, and we're like, all right, now we're going to move it here. We got here, we're like, crap, now we got to govern everybody. You know what I mean? And then you, through a lot of hard work and intelligence, you've come up with a game plan that is hopefully better than what was before.
Yeah.
So maybe Mars is even cooler than Earth. You know? Who knows?
Definitely. And just, I don't know, just to be on Mars and thinking, like, we did it, like, we started to conquer the solar system. We're not just stuck on one planet anymore. We're now expanding, and I don't know. That to me is so excited.
I wonder how difficult life would be, though, as for like the first set of people colonizing it. It would probably be such a difficult life.
I'm sure. Yeah.
But
I mean, just building the infrastructure. That's
everything. There's literally nothing there right now.
That's everybody's goal together, right?
I guess you'd all be in it together, though, but...
Yeah.
Wild stuff.
Really, really wild stuff.
Kayla says you're going home. See ya. She's staying with the cats.
Yep, she's staying with the cats.
Can you bring your cat to Mars? For a small fee.
Yeah, for another $100,000.
You can bring your cat.
Number 7. According to NASA's Goddard Institute for Space Studies, May 2017 was the second warmest May on record globally. Quote, May 2017's temperature was 0.05 degrees Celsius cooler than May 2016. It was just 0.01 degrees Celsius warmer than the third warmest May, which occurred in 2014. End quote. According to the article, the analysis is assembled from data acquired by approximately 6,300 meteorological stations around the world, ship and buoy-based instruments measuring sea surface temperature, and Antarctic research stations. And we can take a look at the Land Ocean Temperature Index, or LOTI map, provided by NASA and the Goddard Institute for Space Studies. Kyle, if you wouldn't mind bringing that up for us, we'll take a look at it. And so... we can see here, Tom, that kind of the bigger swells in temperature rise, if you will, occurred a lot in the Antarctic down here. That's where the redder splotches are. And mostly in the Sahara Desert.
Where there's probably increasing desertification, I think that's how you say it.
Yeah.
So that kind of makes sense, where it would be the largest increase.
Yep, that makes sense. Over here on the East Coast of the United States, doesn't look like too much of a variation. So, maybe we didn't feel it, right, as far as being a hotter May than previous Mays. But
the whole planet, yeah.
But overall, right, when we're talking about the whole planet together, second hottest May on record. So that speaks to something.
Yeah, I mean, all the hottest ones are now.
Yeah.
Within the last few years.
Yep. So, it's happening, folks.
It's getting warm.
It's happening.
It's another scorcher out there.
Yep. And with that, Tom, that is all of the news. We actually went through it a little bit quicker than I
Me too.
anticipated.
I thought we were going to be way over it this week.
Yeah.
We were cruising.
We were cruising. So, yeah. So the rest of the show, I mean, we have 15 free minutes. We could do a Tom's Corner if you feel so inclined to do one.
I think that's a good idea.
Okay.
So, for this week, one of our buddies, we got into a little bit of a tussle on Facebook.
Yeah.
I mean, I do appreciate where he's coming from, because he's a good-hearted guy, our friend Gerard. And we were trying to talk about global warming and climate change. Again, a hot topic, because it's all over politics. And there was that recent video of the guy who started the Weather Channel.
Yeah.
And he said some pretty unexpected things about climate change, saying that it's not really happening. So I just wanted to have a little back and forth with you and me, kind of trying to explain because as people try and do their own research more and more, they find out a lot of really fascinating stuff about Earth's past that they might not have known. And then trying to take all of that new information and catalog it into your existing knowledge and then to get a clear understanding of what's happening right now is kind of difficult. So I think if we just go back and forth, it might make a little more sense, and we might be able to spread this out to more people.
Yeah, sounds
so
good.
A lot of the ideas that have been getting passed around are, that I've seen more recently on social media, is that, you know, in Earth's early history, it was a lot warmer and a lot colder, and there's been a lot of periods of times when it was the glaciers came in and they go back, and a lot of people see this system as something that, you know, it happens. It gets hot, it gets cold, it gets hot, it gets cold, and when you look at it from that perspective, you're like, you know, it's happening again, where it's getting hotter now. So let's go to our last glacial period. So once the glaciers come down, it's sort of like a feedback mechanism, right? That as the whole Earth gets a little bit cooler, as you get more snow, that albedo is going to push off more of the radiation that's coming in,
right,
and it sort of just helps it get cooler.
Yep. So by albedo, we kind of mean that the surface,
when you have
coloration,
white doesn't absorb that.
Right. So we're actually, as more snowfall starts to increase on the Earth, you get more reflective nature to the Earth. So sunlight that strikes the Earth doesn't get absorbed as easily. It actually reflects away, and that can turn into a positive feedback loop where then the Earth continues to get colder and colder, and winters get heavier and heavier with snowfall.
Exactly. And when the feedback gets super, super strong, we actually have some evidence that there was a snowball Earth, where the whole Earth was basically in almost like an ice age.
Right.
So just looking back at that, it may seem at first glance that this is a pretty wild system, and that it gets really cold and it gets really hot, and how the heck can we have any impact on this? All right, but here's the kicker. So after we were in a glacial period, right, now we're out of the glacial period. So the whole Earth is sort of in a warming period, regardless of if people were here. Say we were an alien civilization that had all the data that we have of Earth, and we were looking at it, we would say, okay, they came out of a glacial period, there's going to be a period of warming. But here's the main point of the climate change and global warming. It's the rate at which we're warming. So we know, well, we don't know exactly the temperatures and how fast the warming was, but we know the rate that we're warming right now, and it's a lot higher than we would expect it to be for coming out of an interglacial period. The rate that we're warming is kind of alarming, because when we extrapolate that rate over the next 50 years or 100 years, and then we sort of go through the science, this is why we need to keep doing research on the climate. As we look at what the Earth would be like with these temperatures, and we know the rate that we're rising right now, it doesn't look good. So we know the rate and we know where it's going to be, and as we sort of extrapolate what's going to happen, you know, it's like it's pretty bad already with just the rate that we're at right now. And almost the entire majority of climate scientists say that the amount of greenhouse gases that we've added have contributed to a significant amount of that rate that we're in right now.
Right.
So that's the thing. It's the rate that we've contributed to it, and we're only making it worse. So when we look at 50 years or 100 years down the road, those temperatures of the global temperatures, those might offer some extreme, horrible conditions that we're going to have to adapt to.
Absolutely.
So you got to start now, right?
We see it on the horizon, right?
We can see it there.
Climate scientists, people that study the climate, are seeing this as a potential big problem for future generations, right? For our generation now,
because we know the rate.
Right. It's starting to happen now and could potentially get out of control if we don't start mitigating what we are doing to effectively contribute to carbon dioxide emissions and the warming of the Earth via the greenhouse effect. So whenever you start to bring in the science behind how global warming events could occur, I feel like the antithesis to that argument is, well, there's still not a good causation to correlation between the upswing in the data, right, the rate that we're talking about, and the rise of the industrial age of humans, basically. Even though that is where the graph upswings,
Yeah.
we can't say for sure that one has that effect on the other. That's true, right? I agree with you there. We don't have enough data to say that that is the causation, right? However, we
kind of do though at the same time, because we know how much CO2 emissions we've put out there, right?
Mm-hmm.
So we know the amount of CO2 we've added in there, and by measuring how much warming comes from greenhouse gases in general, then we take the percentage that we've added to it, and we can sort of tell that this much of the global warming due to the greenhouse effect is from the amount that humans have put out into the atmosphere. But we're not saying that all of the warming that's happening right now is from human activity.
Right.
We're saying that that portion that we've added out is making it rise the rate that it is right now.
True. Even still,
Okay.
right? Even if we disregard that entirely and we say that, well, it's not 1-to-1, and you know,
can't say for sure.
We can't say for sure, right? There's uncertainty in that. There's not enough evidence or data to be collected because, you know, we've only gone through one industrial revolution ever, so, you know, there's not enough evidence to say one versus the other. Even all of that aside, I think that the fundamental thing is that, especially in our country, people don't want to invest money into doing climate research when they feel that the predictions made about the catastrophes that climate change will induce have not come true yet.
Yeah, it's hard to say exactly, like, to feel that it's an issue when you go outside every day right now.
Right?
It's hard to say, like, oh, it seems fine, you know? It seems like it always has.
Yeah, nothing's changed for me, you know? And I understand that, right? Because there were a lot of predictions made, and many of them haven't really come true yet. But what I would say to that is it's important for us to continue to invest in scientists who are monitoring these systems and who are rigorously studying these systems, because yes, the Earth's climate has changed, fluctuated over millions of years, and it will continue to do so going well into the future, and it's always fluctuating, and there's no way to really stop it from fluctuating.
Yeah,
but
I think if we actually tried to somehow stop it, we'd probably do more damage than help anyway.
Right.
But what we're trying to do is just mitigate the rate of right now, because it's potentially damaging in the very near foreseeable future.
And we need to understand right now what systems that we depend on are going to be affected by variations in global temperature.
Yeah, so even if we weren't the ones changing it, we need to study this climate and know all about it.
It doesn't even matter if it's because of us or not.
Yeah,
it probably is because of us. Almost certainly it is because of us. But it's so important for us to, you know, to figure out what's going to happen to our pollinators, you know,
as the climate rises.
As the climate rises a few degrees, right? Is that why all the bees are dying off? Like, we don't actually know. And if that is the reason, what are we going to do in order to pollinate all of the crops that our food systems rely on? That's a huge issue.
Yeah,
huge issue.
This is an ongoing issue that is only going to get worse.
Right?
Yeah.
What's going to happen to all the infrastructure in places like Alaska, you know, and Canada, where
all their permafrost melts where all their buildings are, and
right?
whatnot.
Do we just say, oh, well, that's not our problem, so we're not going to invest any research into trying to determine when that might start to occur and mitigate that risk, no, let's just forget about it. We'll just clean up the mess afterwards. That's probably going to cost more money in the long run.
Yeah,
right?
Definitely.
What's going to happen if sea level rises to the point where the Maldives goes completely underwater? This is something we were talking about last week.
Yeah.
Like, what does the UN do with all those people that have lost their nation? In a
Literally
sense?
lost it, yeah.
We've never had to deal with something like that before. These are all things that we can see on the horizon, and climate scientists who are scientists in their own discipline, right? I don't know why they're kind of brushed aside as like
many other ones.
Yeah, like I don't see where people feel like they have the authority to say like, well, this isn't important enough. Or
like I think there's too much uncertainty, whereas the people who are doing the science are saying, no, we kind of know this, you know, like we've been doing this our whole lives, and this is it, you know, like it's a hard pill to swallow for some people, especially when there's people in power who aren't fully versed in the entire scientific literature, and then that sort of gets passed down to the legislation a little bit, and then if you're a part of that side, it's hard to say that, oh, they're wrong on this but they're right on that, so you know they're probably right on everything, is sort of the kind of thing that gets, I think, adapted sometimes.
Yeah, and I don't understand why it would be detrimental to start mitigating the risk now when we have the greatest chance to affect change. Right. We're not playing catch up just yet. Maybe. I mean, hopefully.
Yeah, hopefully not. But
we have this problem that's coming, and it's something that we can hopefully deal with right now if we put our best minds together in terms of coming up with solutions for it. And I just really can't get over the fervor of people that want to fight against this. I don't understand it. Where does it come from? Like,
yeah, we sort of talked about it before on the trèSci episode, where if Al Gore never brought this up as a platform, the world would be a different place.
Mm-hmm.
If he never opened his mouth and said, this is what I'm running on. Because whenever you're running against somebody, there's a winner and a loser, there's right and wrong, and science was never really a part of that. You know,
and it shouldn't be.
And I agree, it shouldn't be. And it's almost gotten out of hand to the point where you don't even know what to read on the internet about this topic sometimes, because there's so much stuff out there.
Yeah,
and it's just, I don't know. It's wild to watch. But the last thing I want to leave us off on is we're getting warmer. We came out of an interglacial period, and we're in a natural state of warming, and we know the rate at which we're warming. And regardless of if we made it warm, if we're the direct cause of it, in 50 to 100 years to 150 years, the rate at which we're warming right now is going to raise dozens and dozens, hundreds of obstacles that we're going to run into because of this temperature rise. Mm-hmm. And we know the rate that it's rising right now. And we have put out all kinds of greenhouse gases, which we know what greenhouse gases do. And these climate scientists, who are the ones telling us that this is adding to the rate of the rise, you really got to take a step back and think about tackling these challenges, I think, and getting over this debate argument that was created because of a political platform.
Yeah.
You know, that kind of, I feel like, is where we're at now.
Yeah.
And I think over the next few years, people are going to come to realize that it's not just an agenda to like win or anything. It's just weird that it got brought into politics the way it did.
Yeah, I hope you're right, because, you know, I mean, we say it all the time. You trust the astronomers, right, when they tell you that we found these 219 new planet candidates, right?
Nobody says, I doubt the transiting method of...
Yeah.
You know, they're like, okay, yeah, I guess so.
That's totally fine.
Like, I'm not a NASA scientist, so I don't know.
Yep. Yeah. You trust the biologists when they tell you, now we figured out how the ladybugs fold their wings up. Okay, that's fine. Trust your climate scientists. They know what they're talking about.
And then the last thing, I don't think we brought it up. If you wouldn't mind just popping it up, there's a link that we wanted to give to the NASA website, and it's nasa.gov/ what was it? Effects? Yeah, effects. And they have a whole beautiful page of just information of the best evidence that the climate scientists can sort of try and convince you the way they've been convinced by the data.
Mm-hmm.
And it's good stuff.
Yeah, really, really great.
They have all kinds of different articles explaining how each part is a part of the climate change, how we've got it from the ice cores, and I would definitely recommend going to nasa.gov/effects.
Yeah, I agree. Really good stuff there. I was browsing through it before. And yeah, I mean, this is NASA putting it out there. Same people that put people on the moon. So
Back in the 60s.
yeah. All right. So I guess that's all for us this week.
And hopefully next week we're not talking about climate again.
Yeah, we'll see.
You never know.
Never know. Next week will be a special week. We'll have our first guest
that's
on the
exciting.
show.
That's very exciting.
So we'll hopefully have you guys all join us for that. With that said, have a great rest of your week, guys. And
thanks for stopping by.
Thanks for stopping by.